Hey guys, welcome back. This is a 3 PCB Space Invaders by Taito set. I believe it was said to have some sound issues. I'm just doing some filming to see how this thing is put together, so I put it back together right. This looks like the ROM board, which is like this. Folded over onto the CPU, and there's the RAM board. So you got CPU, RAM, and ROM. And then on the other side, connected through these two guys, is your soundboard. So I'm going to go ahead and separate all of these and go from there. Okay, this guy's together. I have to fold this board over and just kind of put something to shield it in between. But I've got it hooked up, and this thing's acting a little funny, and it just screams of bad connections. I mean, if it's getting this far, it pretty much is going to tell me that things will work right. It's just acting really goofy. That kind of, it just screams to me of bad interconnections. So I'm going to have to try to clean these guys up. I think I'll soak these in some simple green and go let them soak for a while. I'm going to reseed everything, and then we'll come back to it. Okay, I'm going to let the camera roll on how I go about these things. I'm resoldering, and you can't just flow solder into these because this is so oxidized that it's like a 3-step process to do, and it's extremely tedious, but you'll see the results are well worth it. I've already done one of these, but the first thing you're going to do is actually, let me put my glasses on and let me make sure. I gotta make sure that that's still in the frame like that, and it is. Let's even see if I can. And yeah, that's pretty good right there, right? Yeah. Okay. I'll keep the big magnifier out of the way. I'll put my super magnifying glasses on. Okay. First thing I'm going to do is I'm going to flow some solder into this stuff. Just kind of sloppily, it doesn't matter. This is actually flowing decent. The last one did not flow decently. But in case you run into these that don't flow good and the solder just sticks to your soldering iron, it won't cooperate because it's so oxidized. This is actually flowing pretty good. But I'll do it anyway just to show how I do it. Normally, since this is flowing pretty good, I would leave this alone after doing this. Okay. I'm going to get this magnifier in the way a little bit. Check it out. Yeah, that looks pretty good right there. I would normally just leave that alone. There's one right here. It's funny how solder will flow decently on one side but not on the other. And that magnifier's not in the way like that. So anyway, this is what I do after I flow it like that. I'll go with my desoldering iron. Okay, so that's all cleaned up. Now, I'm going to move in my my smoke getter, or whatever you want to call it. And I'm going to see if I'm still in frame here decently. Let's move it just a little bit. Come on. Okay. Trying to move a little bit. Okay, now you can see we're good to go there. I'm going to turn this on. Actually, I've fluxed this really good. This is no clean flux, which really just kind of means less clean flux. You still got to clean it. So I'm going to turn this on. You need to use one of these if you're using flux, because the fumes will smoke you out. I'll turn that guy on and just start going down, soldering. Then you get a really good like new solder joint on all of these guys. Then I always reflux after I do that row. And go through and do the top. Okay. That is it. And now I'm going to go ahead and take and clean this stuff up. Okay. And now I'm going to grab the camera. Okay. And we will come down and take a look. And you'll see just how good and new these joints look. And I have also done this side. So this side has been done of this board. I'm going to go ahead and continue on, do these guys, and then do the connectors on those two boards too. I will be back. Okay, all of the connectors have been resoldered. I put the thing back together, and I actually hooked it up to my color monitor. And it's still acting funny. It's still resetting. Yeah, see, it's just kind of getting lost, it looks like. So I think what I want to do is hook the fluke up to this and just do some, exercise the thing a little bit. So I believe that's what I'm going to do. Yeah, it's acting funny. So I think the first thing I could probably do is try replacing these two connectors, because these are the ones from the CPU board to the ROM board. So I could try changing out those two guys and see if it makes a difference. I don't think it will, though. I don't think this is a problem with that. I think this is some kind of a problem. I'm not exactly sure. This could be an issue on the game PCB, though. I think a good thing to do first off is I might even remove this board altogether and just go with the ROM and the CPU and RAM board and run some tests on it. I think that's what I'll do. But I think first thing I'm going to need to do is dump these EEPROMs. Or I'll look for fluke information on this and see, because I don't know if this 10 ROM set is in MAME. I'll have to look it up. I got to do a little research, so I'll be back. Okay, I am performing. I have my fluke hooked up to this guy, and right now I'm performing a long RAM test on the working RAM section of the PCB. I'm doing a RAM long because a long test looks for soft errors, whereas a RAM short is like it looks for hard errors, anything that's like obvious. This thing will really exercise it, and it'll find little, if a chip is just a little flaky or whatever, it'll find hidden problems. So I'm doing long RAM tests on this, and this looks good. All the RAM seems to be good. The ROMs seem to be good, and what I had to do with the ROMs is this is not in MAME as 10 chips. The software, the only version of this software in MAME is the 5 chip version. So what I had to do is I had to split them. I had to use the MAME debugger and split the whole ROM file into 10 files, and this is what I came up with. Now these are all the address ranges over here, and you use the debugger just to split these, the debugger. And then I used Fluke CalcSig program to calculate the signature, and then I verified all of them. And this is the RAM is split up this way. You know, the working RAM, the CPU's program RAM is 2000 to 23 FF. And then the video RAM is broken up into segments, and it shows like in 5 or 6 segments on the screen. This is the first segment, second, third, fourth, fifth, sixth, and seventh. So there's actually 7 sections on the screen that's broke up like this. The first one, 2400 to 27 FF, is like right here, and then the next one, 28 to 2 BFF, goes up to here. All those 7 segments work across the screen, is how that works. Those all tested good, and my RAM long test is also good. Now I'm going to do a long test, which is going to take a long time on the whole video RAM area, and I take it that that will be okay. I think my problem is this board right here. I think this is what the issue is this guy, this game PCB. The sound PCB is the problem, I believe. But I'm going to do a long test on the video RAM. I'm going to exercise the ROMs a little bit more, and then go from there, and then start poking around on this guy. This is going to be the problem. I'm going to have to figure out a way to open this up too. So I think what I can do is just totally flip this over and have this guy folded and have this guy straightened out on the other side, so that I can get to this guy. Alright, I'll be back. I'm in the middle of my long RAM test on the video RAM. And it's doing great. I did go back in on the MAME debugger, and I dumped the whole and got a signature of all of the ROMs from address 0 to 1FFF. That's like all 8 of the ROMs. I'm going to do a ROM test on all 8 at once and make sure that it it comes back good. And then from 4000 to 47 FF, I'm going to do the all the ROM checks on that, on the whole range, all at once. So well, I can do 0 to 1 FFF, and then I have to do 4000 to 47 FF separate. But I want to be able to do a ROM check continuously. Because that way it's going to the system's going to be accessing all the ROMs in continuity, without having to stop and punch it in and whatnot. So, all right, that'll be next. Okay, I had tested all of these ROMs before and they were good, and now I'm having a problem with ROM access. You can see the first ROM is 0 to 3FF, and it's a signature of 7309, which is what I have programmed in here right now. I'm just going to hit repeat. And now it's failing, and it's failing. It's giving me a different CA07. It's giving me something different every time. CA07. I'll try it again. This time it's D0AB. So we have access problems to the ROM now. So I'm going to have to look into that, and I'm going to have to get a schematic out for this guy. And I know the 3-board set schematic is readily available, I believe. So I'm going to look at that and look at the, look at how the data is getting buffered back, because I think we got a problem with that. So let me go ahead and look into that. Okay, I found a very interesting pattern. Now, if I do this range, 0 to 3FF, or this range, 400 to 7FF, I will get A992 on either one of those ranges. So it's not selecting this guy, it's only selecting this guy for both of these ranges. See, I'll do this. Let's go with a ROM 0 to 3FF, and that is supposed to be 7309. And it comes up A992, which is supposed to be 400 to 7FF, A992. Now if I do 400 to 7FF, that is supposed to be A992. This one will be okay. Okay. Now let's go back to 0 to 3FF, 7309. And it fails, and it is A992. So it's always selecting these two ranges. It's only selecting this chip. And I can, that's with all the ranges. Now see, 800 to BFF. You got a ROM at 800 to BFF. And that is supposed to be 80F4. And it fails, and it is BFB3, which is BFB3, which is actually C00 to FFF. So either one of these gives me that. So it's not selecting these ranges. It's only selecting four ranges basically instead of 8. Now I'm curious down here, 4000. I'm going to try that. That's supposed to be 19C9. Oh, it's supposed to be 19C5. And that comes up something crazy. Let's try that again. It's supposed to be 19C5. And you see, that's just random nonsense, that one. Let's try 44 for 7FF, and that is supposed to be 8CB7. And C3FD. I'm going to see if it comes up with the same thing. Nope. And let's go back to a ROM at, okay, let's do 14 to 17FF. And I bet you it comes up 2098. And this is not correct. A76E, which is totally random. Let's go back to this. Now remember, this one was giving me A992. Now it's giving me 0093. So we have decoding problem big time on this. So first thing I'm going to do is look at address decoding for the ROM. Now if I do RAM, RAM is great. I can do RAM at 2000 to 23FF. That's the working RAM. Actually, that is supposed to be working RAM, and watch this. I'm going to repeat. You see how that's doing that? Only video RAM should be doing that. Working RAM should not be doing that with the screen. I'll hit repeat again. This is 2000 to 23FF. That is the program RAM. So we have, I mean, the RAM is coming back good, but it's the wrong spot. There's a decoding error in the RAM as well. So I have to look at address decoding. That is 24 to 27FF is that range. That it was just checking. Now it comes back with no errors because the RAM comes back, but there's a decoding error, addressing error. So I'm going to have to look at the schematic and find out where the addressing is going awry, because that's the problem. There's an addressing problem on this board. So let me find a schematic and start poking around. My initial thoughts of this soundboard being the problem is not the problem. It is an addressing problem on this guy. There's a sound issue. That's what this board was sent to me for, was there was sound problems. But it's a good thing he sent them to me, because this thing has addressing issues too. It needs to be cleared up. So let's do that. Let's yeah, I'll have to find a schematic and go over that. Alright, I've been out here poking around on this thing, on this CPU board a little bit, and this thing is running solid right now. So I'm not really sure what the heck is going on with that. One thing I don't like that I saw, and I'll show you, is this 153 right here. One of the outputs, if you look at the voltage up here, okay guys, well, I'm back looking at this Space Invaders Part 2 set. I actually did some work on it the last couple of days, and I didn't film it because my battery died in my camera and I just didn't charge it. So I'm charged back up, and all I've really done is some more just run testing, and I replaced on these boards here a couple of parts. I replaced this socket because it looked like it had some damaged pins, and I replaced this guy right here, which is a 153, and the reason I replaced that is because the output on pin 9 was only getting up to not even 3 volts. So it was just a weak low, a weak signal, a weak high signal. It was only getting up 3 volts. That was it. It wasn't even hitting 3 volts. It was like 2.8, 2.9 volts. It wasn't bad, but it was on its way to being bad, so I replaced that guy right there. This socket, I cleaned this chip. I cleaned all the legs on this chip, and I replaced that socket. I am going to have to replace some of these amplifiers, because it is missing two sounds. It's missing the fire and invader hit sound. So that's just two of these guys. That's no big deal. My main concern with this set is this board right here. I just took all of these ROMs out and I used my Dremel and a wire wheel and I cleaned all of the legs. And the sockets on here, I will remove a chip and you'll see. This has the type of sockets that like pole position uses, to where it is alright, sorry about the interruption, but what I was saying is these sockets are like what you find on pole position. They're one side swiped. They swipe on the inside of the chip legs only. So what I did was I sprayed like a lubricant, this stuff right here, inside the sockets just to clean them up, keep them lubricated, keep them from rusting and corroding and whatnot. And I cleaned the legs with a Dremel.
You don't need this old glider out here.
And I keep getting interrupted. Like I was saying, I cleaned the legs with the wire wheel, and I've got the legs going inward. See, you want them going inward so they swipe that socket good. So they go in just like that. That way they really swipe that socket good. Now I'm going to put it back together after cleaning them up and bending all of those legs in a little bit so it straddles them sockets good. Because this thing's been resetting on me pretty much constantly. I can't get it to run. And I think it's I think that the program is getting lost, is what I think's going on. So hopefully that takes care of that. So let's hook this thing back up and see what we get. Okay, we're hooked back up. And I have it on. So far, so good. And there's a reset. And there's a reset. And there's goofiness. I'm going to let it go for a while, see how it behaves. And I'll be back. I'm doing a little fluke work, just kind of doing a little ROM hammering and stuff. But I want to show you this chip that I replaced. Remember, the output on pin 9, it was about 2.8 volts tops. I replaced it, and you'll see, I'll get on it. That's the signal right there, and you'll see up in the corner 4.6, it hits 5. It's right up near 5 volts, which is, that's what you want. when I was probing this signal before, it was under 3 volts. So that just wasn't good, so I replaced that. If you ever see anything like that, if your scope can tell what the peak to peak voltage is of your wave, you want it to be around 5 volts. You know, at least 4.5 volts is healthy. So, you know, 4.7 to 8, 4.75 to 5 volts is ideal. You know, so, but these things get internally worn out or partially shorted, and like that one was under, not even hitting 3 volts on that output, which is not good. So, alright, I just wanted to show that real quick. I'm just kind of probing around on this board and finding out, doing some ROM checks and stuff. I believe that's my whole problem, is this board. This board's flaky, I believe. So I'm going to keep messing around. Alright guys, I'm seeing some really silly stuff. First off, a lot of these signals on these 7408s, and the 7408s I know buffer the addressing. I'm not going to say I know. I'm pretty sure. And there's 3 chips, 3 7408s right here. And they buffer the addressing to these guys. And check these signals out. Let me find. Look at this guy. It's kind of floating. This is a good signal. You'll see remember up there? This one's way up. This is a strong signal right here. That is probably right off of a driver, and it's driving it up over 5 volts. So that's a great signal right there. And then there's this. That's half floating nonsense. And then there's a handful of these also. See, this is that same signal, which is an input to another side of these chips. That is what is screwing this board up right there. So I have to figure out what that signal is, where it's coming from, because that's my bad part. So I'm going to look at the schematic and find out what is the common output or input for these guys. There's a common input. This guy, and this guy have a common input on pin 2. And I need to know where that's coming from. Okay, yeah, so let me figure that out. I'm going to look at the schematic, find out where that is coming from, because it's that's my problem. So let me find it. I will be back. Okay, so I got one of my clips on one of those 7408s, and I'm clipped to the leg of a pull-up resistor. That is pulling those inputs high, is what it's doing. Because these are supposed to just be buffering the address, right? You got one input and then a pulled high input just to buffer the input on the output. One of these is internally shorting to that. One of these 7408s is bad, is what it is. So I am going to remove all 3 of them and replace all 3 of them. But let me take care of that and I'll be back. Just so that you see, this is, I'll hook this up to pin 2. So So they are pulled high. They're supposed to just be pulled high. So I believe that one of those 7408s is actually, you know, it is shorting to that, to one of the address inputs is what's happening, I think. So I'm going to go ahead and replace all three of them, and hopefully that will fix the whole problem. So I'll be back. Okay, we are back together. These three guys were replaced. 1, 2, and 3 7408s, and those they buffer the address bits, is what they do. And if we take the scope and we now look at pin 2, you'll see it is pulled high, just how it's supposed to be. And more importantly, we are now running without any errors or flake outs. Excellent. So all that remains now is to replace the two bad LM3900s, which correlate to the fire sound and the invader hit sound. So that will be it. Let me go ahead and kind of situate this thing. I got to turn this board set up the other way so that I can get to the soundboard on the bottom here. But that'll be it, and that'll take care of this guy. So I'm feeling good about these buffers being changed out now. That's all squared away. I'm feeling really good about replacing this guy, because that would have been a problem. That was on its way out right there. Because that signal just kept going down and down and down, and it was at about 2.8 volts for the logical high is what that one was. But all right, goody goody. That's all good to go now. So we'll go ahead, flip this thing over, and we'll start looking at some sounds. Okay, now I got the stack flipped around so that I have access to the soundboard. And I'm going to set the camera up, and I'll play the game, and you'll see the sounds that are missing. And I'll have to do some research to find out which chip correlates to which sound. And then we'll replace those 3900s and test it, and that should be it. Well, let me go ahead and set up. Okay, and we're ready. I got some lights killed for better effect. And we'll go ahead and coin up and start. You see, it's the fire and invader hit.
try these.
Okay, so now I'll go ahead and fix those two sounds and I'll be back. And here is the sound slash game PCB. And as you can see, I have decided to go ahead and just replace all of the amplifiers, all 7 of them. Make it a little more solid for the years to come. So yeah, because they're bound to go out. So nice and fresh. So I'm going to go ahead and put it back together now and we'll fire it up. And I think it was missing the thump sound, if I'm not mistaken. I don't remember hearing the thump, 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 thump. So we'll see. Let's put it back together and see what we get. Okay, and we're all put back together. And we'll go ahead and set back up. And I'll go turn the lights back off for better effect. And I'll go ahead and coin up and we will play a game. And there you have it. All of the sounds are back. The thing is not resetting anymore. The thump was there. The thump sound was there. You can just turn it up or whatever, I don't know. But yeah, it's there. And it's playing great now. No more flaking. Good to go. Space Invaders by Taito. 3-board stack. Pretty cool. I'm not sure if I lost some video on this, to be honest, guys. If I did, let's do a recap of what I did to this guy. I did a lot of maintenance work. I re-soldered all of the interconnects. All 1, 2, 3, 4, 5, 6, and 7, and 8. All 8 of them I reflowed all of the pins. All of the solder pins. I reflowed all of them. Not reflowed, I resoldered. I removed and reflowed all the solder. Obviously, we did all of the amplifiers on the soundboard. I cleaned this chip and replaced this socket. On the ROM board, I replaced the 3 74LS08s that were, one of them was dragging that line that was supposed to be pulled high. one of them was kind of dragging a signal through to it, and every now and again it would flake out the addressing to the ROMs as well. That's what was happening. That's why it was flaking out. I cleaned the ROM legs. I bent them inwards a little bit so that they would grip them sockets better. I cleaned the sockets. Did not replace, I cleaned. The CPU board, I replaced the CPU socket. And I replaced that one LS153. You remember how I explained how it was only driving up to about 2.8 volts for a high signal. So I replaced that guy. And I believe that's about it. So this thing should be good to go for a while. It should be good to go unless something else fails on it. If nothing fails, it'll be a good solid board with solid sounds anyway, and easy to replace from here on out. So, all right. Well, as always, everybody, I sure do appreciate the support and you guys watching the videos and everything. If you haven't subscribed, subscribe. If you liked what you saw, like it. Heck, if you didn't, dislike it. That's cool. Either way, I appreciate the feedback. All right. Space Invaders Part 2. Color. Space Invaders Part 2 in Technicolor. Coming to an arcade near you. Cool. All right, guys. We'll see you on the next one. Peace out. Thank you for watching. See you next time.